Okay, trying to add to this video. So what I'm actually doing here is I'm actually turning the gate off on with my Lambda power supply. I have it to 15 volts on the gate. Did some research lately, and it's better to probably run them up around 15 volts than I was at 12 volts. You have to kind of know your MOSFET data sheet and read it over and everything. You can usually see as you up the voltage, it gives you a little less voltage drop through the MOSFET, which means it's going to run cooler, which is a good thing. Have my FLIR ready to go there. As right now, it's just on the bench. You can see the soldering iron looks nice and hot. That's ready to change out the source. The wire I have basically soldered on the source there. I'll try and clean my camera lens a little bit here. It might be a little better. Nonetheless, 2 LiPo packs in series. What I have here is a motorcycle load cell or motorcycle battery load tester shoved in a bucket of water. Cool it off, keep the amperage up a little higher. I have an amp sensor, 400 amp sensor, reading the amperage. It's reading it in reverse, so that's fine. I'm using my oscilloscope to measure that, and I'm powering the driver stage. I need the 10 volt regulator to work to power the current sensor. So what I'm doing is I'm actually upping a LiPo in series to get the higher amperage, because this the little wires, I can't remember what you call that stuff, but the wire that gets hot, the little heater element in the battery load tester actually gets hot really fast, and it basically just gets hotter and hotter. So you have to keep it cool in water, and then the only way you can up the amperage with that system is to up the voltage. So this isn't dangerous. I'm kind of expecting to get 2 to 3 packs. This is a 4110 MOSFET. Don't expect a lot, but I brought some 4115s, some IX FK230N20T MOSFETs, a couple of a 4468 and a 4568 MOSFET, a few of them. Do a little bit of playing with that. So basically, I think what I'll do is I'll start this camera. I have my safety glasses on because I'm actually planning to blow the MOSFET up. So I'll try and set my phone so it can record that while I hook the wire up. I would like to have a better system for this, but it's kind of hard to do. Set that there. Oop. Let's stay. Now. Just get a quick reading here. Shit. Oh, getting hot. Look at how hot that is. I got that nice and hot in there. You can see all that power was boiling water in my bucket there, basically. That was pretty cool. Holy cow. You can smell it. It's melting into the bucket and everything. I'm pretty impressed. That little 4110, like we'll even kind of get an idea right now. The little MOSFET itself isn't even really hot. Looks to be about 310 millivolts. Just use vice grips that can hold wires together and whatnot. I'm gonna hit this. Basically, I have to attach that wire to there, so I have my welding gloves. Hopefully I can attach this without getting in trouble. And I have a feeling this might blow up because it's 3 sets of LiPo in series. I've done it one at a time, adding one more in series every time. Started with 1, and I was about 45 amps through the 4110 MOSFET. Hit it with 2, I was about 85 amps, I think it worked out to. And then now I'm about to hit it with 3, which should be a little over 120, maybe 130 amps. This is where it should blow theoretically. Let's see what happens. There it goes. Jesus. That little son of a bitch is actually able to flow that much current. Let's see if we can get this. My phone might be upside down. Look at the heat in that MOSFET. So, this is crazy. There we go. That's the end of that MOSFET. Okay, I had some success with 3 lipo packs in series running a 4110 MOSFET. It worked out to around 130 amps through the damn MOSFET. It's incredible. It did blow up, loading it down like that twice. So it's obviously not going to last long, but it seemed to be not a problem for a 4110 to run 89 amps. Anyways, this is a IRF P4568. This thing's rated for a little more. It's a bigger surface area. It should conduct the heat out quicker. I'm going to go straight ahead and try 3 lipo packs in series, which should put quite a bit of amperage to it. Let's see what happens here. Jesus. Look at how bright red those were right away. Let's try and get a shot here. Take a picture. Look. You see the heat in the MOSFET. I have my zoom set a little funny, but yeah, you can see how, like, we'll try and focus on the center. The spot is showing 30 degrees Celsius in the center, somewhere 31. And if you look over here, the aluminum itself is 12. So the heat's not pulling out that fast, but it did take it for a little while. Like, look at these wires. That's a pretty thick wire. It's nice and hot. The whole thing. My batteries are all warm. Everything's warm. But this will tell me what I was flowing for amperage through the last one too. 520 millivolts. Basically from there, which is 0. So we'll back down just to verify. It's 520 millivolts. Come on, zoom in, you fucker. Okay. What I'm doing here is a quick load test. I'm actually flowing power through an IRFP4568 MOSFET. I've already successfully dead shorted. It's not a dead short, but flown 147 amps through it. Basically flow through there, through the current sensor, through all the 3 packs of lipo in series. Now I'm running 4. Then I have a battery load tester in a bucket of water there to try and keep it cool. It will get hot very fast this time, and I'm pretty sure this MOSFET's just going to blow up. The last time I tested it, I actually have a thermal imaging picture with my thermal imaging camera here of the MOSFET. Nonetheless, I have a picture showing the source leg glowing on the inside of the MOSFET, which to me means it's about to go. Like, it's just about done. And it was at 90 something degrees Celsius. It's only rated for 121 degrees Celsius. 121 amps at 100 degrees Celsius. So I was like probably past the ratings, which is pretty damn cool. Very cool. So just experimenting here because I want to get a rough idea where I can actually theoretically push these sons of bitches to for a 10-second rating on a controller with extremely good cooling. Right now I have silver paste. I found this stuff to work really well. I'm actually flowing the current in the source leg and out through the aluminum heatsink. And I'm actually using this silver MG Chemicals, I think it is. I don't know who makes it, but it doesn't matter. Silver conductive, MG Chemicals. Silver conductive grease to flow the heat and the current out of the back of the MOSFET. If you look at one of these like this is an IRFB 4110. I blew this up a little while ago doing a test. I managed to pull 140 amps out of this son of a bitch once, and then I did it again and blew up, like melted down the source leg, which is to be expected. It's not rated for that much. It seemed to have no problem at 89 amps though, which is really good. We've seen, you know, what was rated at 50 phase amps on our do-it-yourself controllers, but I think with my new controller design and all the proper stuff done, I can probably push these things as far as 89 amps a piece peak on my phase currents, which is really good. The IXFK230M20T. So here goes. Whew. Here goes. Okay, it's time to test an IX FK230N20T MOSFET. I'm running 3 packs of LiPo in series through every pack of LiPo adds about 45 amps to the system. Actually, I hit 145, so a little more than that. Nonetheless, that hit 145 on a IRFP 4568 MOSFET, which is 147, something like that. But yeah, it's really cool. Nonetheless, I did try 4 packs in series, which bumped it up really high, and it just melted the source pin right away. It blew it up. I kind of expected that. Got it on video. It's cool. Now we're on to there's the source pin. I could tell the video prior to that was about to happen because 147 amps was making the source really hot inside the MOSFET, and my thermal imaging camera actually showed that, so it was really cool. Definitely a handy thing to have, and especially for what I'm trying to accomplish here is just verify some datasheet Kool-Aid, and these will actually flow the amps they're rated for, but when you're using them in a 3-phase motor controller, you have to understand that even though you might think you can hit some really high amperage with them, what actually happens is you're hitting peaks on phase amps, and that doesn't equate to the same amount by any means of battery DC amps. So usually your DC amps are a long ways below what your peaks on your phase amps are. So for instance, if I was to push a peak of say 147 phase amps through one of these, I would probably expect to see 60 to 70 DC amps with a properly set up controller running really well and everything. Maybe the cleanest waveform you can. Once you add some field weakening, that can change, but that's a whole other story. Anyways, I'm going to hook up my alligator connector to the LiPo connector. I have everything ready here, so I should be able to do this. Start there. And then if something goes on, hopefully it's on video. Yeah, it's nice and warm. Everything, this thing glowing red. Let's see what we got here. We'll get a picture with this. Get a couple. Some of you might ask why I'm doing this. I actually want to kind of compare a few different MOSFETs that I've had my eye on and played with in the last couple of years. This is an IRFP 4568. And then I have an IRFB 4110. These are common MOSFETs that we use for hot rod and controllers. 4110 is a little powerhouse. A little son of a bitch can do over 100 amps, and I actually proved it today. 89 amps seemed to be no problem. Basically, I hit it with what worked out to be about 147 amps, and it lasted for about 5 seconds. Then I shut it off. Then I tried it again, and the next time it blew up. That's pretty incredible for a little 4110 MOSFET. Just a TO220 package, just a tiny little son of a bitch. So if you compare that to that, size-wise, it's tiny compared to the 4568, and then you can compare the 4568 to the IXFK230N20T. That thing has a little more resistance. It's a 7.5 milliohm RDS on, I believe it is. That I'm running all these with the lambda power supply to the gate at 15 volts. You get a little less voltage drop by running a higher voltage. It's a safe number to run them at. Basically, I'm cheating, just running a dead short through LiPo, through battery load tester designed for 12 volts. Usually does about 50 amps at 12 volts. Well, with 4 packs of 16 point whatever volt charge LiPo, it runs a little more amperage. 3 of them in series usually ends up being 147 amps, and that's what the last test did. I used an old blown up power stage with a working current sensor on it, also fed by my lambda power box there to power supply to give the output, and then I'm using the output and reading on the oscilloscope. Seems to be pretty accurate to measure. I also got a meter here set up for voltage drop. So now I'm going to run 4 packs in series. I don't actually expect this to last long, but it's rated for it for a short period, or it'll be close, because 47 amps, yeah, I'll probably be over 200 amps through this whole system. So let's see what happens. I have my welding gloves I'm using to do this. Let's put my other glove on when I set the phone down. And then I'm going to hook the wires up. And we're probably going to see a little bit of welding on the wires, which is a little scary. I got safety glasses on. Hopefully that saves me. And we'll see if this blows up or not. Whoops. See if this blows up or not. Whoops. Yeah, blew up. And I got water on my lip. I'll have to get that out of here. Either way, cool. Shut this off. We'll call it a day for now. So now we know there is advantages to running the. I know you're still recording, so or I'm still recording. There is advantages to running the. Something's over here. It's metal. The IX-FK230N MOSFET, because it stays cooler, and that was a big advantage. And I think it can handle a little more current than my the IRFP 4568. If you look, it actually melted through, cut through the plastic on the housing there. It's pretty cool. Got my thermal imaging camera to look at everything. You can see how hot the MOSFET still is. I have the load tester in a bucket of water to try and cool it. But the part of the reason I'm doing this is because these IRFP 4568 MOSFETs are a lot cheaper than the IX-FK MOSFETs. So it depends on what price you get them for. Now, the other ones are clearly rated for 200 volts versus the 4568 being rated for 150 volts. But a guy should be able to run 28S LiPo, which is what Zero runs in their bikes with the 150 volt rated MOSFET. Because that's what Sevcon basically does. Their MOSFETs are rated at 150 volts. So I'm going to try and set up something to do a better test and get some more data with this. Try and find the actual limit of what I did there is running 4 batteries in series. That's a little tricky. I'd like to be able to vary the current a little easier. So maybe if I could put a little more load on it by adding a little more load or something with 2 or 3 batteries in series. So then I can try and get halfway in between. I have a feeling from everything I've done so far, basically looking at the numbers, 12S is 147 amps, and 8S was 87, so it was like 45, you know, a little less than double, or a little less than 45 added to it every time. So technically, that would have been really close to 200 amps for the 16S.